Hello everybody, my name's Daniel. I'm a software developer who changed into consulting for some years now, and in this video I want to talk about a new project that a colleague and I set up, which is called Cucumber Diseases, that deals with coding smells in Cucumber and Gherkin BDD setups. There are other videos where we talk about why BDD is a good style of development, but this video series deals with how to create good code for using BDD. So the project that I want to talk about is called Cucumber Diseases, and it is a collection of coding smells we identified over the last years that you can encounter when using Cucumber or Gherkin to test your software. So let me show you a bit what we created here. Okay. If you go to cucumber-diseases.github.io, you will be greeted with this page. This page is our main repository where we collect all the smells and exercises that we created over the past months and years. So you can use this page for a variety of purposes, right? It tells you right here in the beginning. You can use it as a tutorial to practice your skills. You can do the coding exercises. You can use it to improve your understanding of coding smells in Gherkin Cucumber. And eventually, and this is what we're still working on, you will also be able to use that for workshop facilitation. So this page, on the one hand, collects some practice repositories that contain a simple application covered with Cucumber tests that include a lot of smells. And you can use these repositories. You know, there's a short explanation how to use them, but their main purpose is to work through them and figure out what are the smells, how can you identify them, and how to clean them up. So currently we support 4 different programming languages. We're looking to expand that at the moment. So we are supporting Java, Go, Python, and C# code. All the repositories have the same structure, have the same layout, work based off the same Cucumber feature file. And you can just clone them and start working on the main branch and then see how far you can get. So what I want to do in this video is I will be showing you how to set up the repository and fix the first 1 or 2 smells of the Go code, because that's what I'm currently working on. So what kind of smells are we talking about? We collected, at the moment, we have collected and published 13 different coding smells when writing the test automation code for Cucumber. So this list is growing. We already have 3 or 4 additional coding smells we did not yet write down, document, and describe. But currently these are the 13 smells. Each of them, and you can, if you go to the page, you can click through them. Each of them is described with, you know, what the smell is, what the impact on your code will be. So basically why you want to get rid of it. And how you can fix it. Like if you, let's take for example, this will be the first one we're going to fix. This is a missing then implementation. How do you recognize it? What will be the impact, and what do you need to do to fix it? And then you will also find some code examples in all the programming languages we support here. They contain annotations you can click on and see what's the problem here. Just to keep that in mind, these smells, if you progress through them, they're getting more and more complex. So the first ones are usually the easier ones to find and understand, while the last one, like that what we call here a test code impurity, that's quite a sophisticated one, where you will have to invest a lot of work. And you can say we did not fully finish the descriptions and implementations here, but never mind. We have also a description here what coding smells are. Essentially, coding smells are just stuff that make it harder to maintain your code over time. And we want to get rid of them because the longer you have them in there, the more impact it will have, the more technical debt you will accumulate. So to create maintainable and flexible and growable code, especially in Cucumber tests, these are smells you should try to get rid of. So just that you know, there is also a kind of rating of impacts. You can see we classify them into 4 things. Like whenever you see these little bugs here, this is basically the stuff that should never ever be in your Cucumber tests, because that essentially makes them useless. Get rid of them, remove them immediately if you encounter them. They are usually grave problems in the test design and technical setup. You will see in the first ones. Then we have those lightning bolts here. Those are grave problems or real problems. They don't make the tests useless, but they will screw you up in the future pretty quickly. So you should get rid of them as soon as possible, like employing the Pathfinder rule, or the Pathfinder rule is called the Boy Scouts rule, employing the Boy Scouts rule to get rid of them whenever you touch the code. And finally, the lower 2, they're kind of like that one that exit. Like, that's a problem. It will not kill you immediately. It will increase technical debt over time, so your future maintenance will be impacted. It won't hurt you right now, but it may hurt you in 6 months or a year. Like, that's kind of the timeline. And then there are these warnings. That stuff that's generally a concern for your code. You will be able to live with that for quite a long time. But over time, the more you accumulate, the more problems you will get with that code. So these are rather warnings related to style, related to really long-term problems that you don't need to get rid of at the moment, but you should work on them. So there we have a collection of the smells, and I'm going to take one smell after the other, maybe in multiple recordings, and go over them, show you how to find them in the code, how to fix them, what to do with them in general. What you can also do with this page is we created the list of deliberate exercises. We are big fans of what we call deliberate exercise, which means you sit down, you work through dedicated examples, through tutorials, you work through learning opportunities like refactoring cutters or similar things. And basically that whole Cucumber Diseases project, it's nothing else than a big Cucumber and gherkin refactoring cutter for improving your code. So these exercises guide you through fixing one code smell after the other. They are always in a setup where where the smell is related. You can see what's the purpose of the exercise. Usually the purpose is helping you identify a specific smell and figure out how to solve it, and then it describes your task. So if at any point you would get stuck, there are these hints. They are hidden behind drop-down notes. So if you look at a task and you can't figure out what to do, let's start with the first hint and go one by one. So a final note: if you think this project is interesting and you think it's worth contributing, we created a small guide on the website how to do that. It's a rather simple approach. We have this organization on GitHub, which is called Cucumber Diseases. It lists all our repositories, and if you go there, you have also that short introduction here. I think there's also somewhere a part about contributing, and how it's set up is basically we have this main repository. So we have this one for the website. We have then for each of the programming languages a different dedicated repository that you can check out, that you can contribute to. So if you think you are missing, for example, some smells, you can just fork the cucumberdiseases.github.io repository, implement or write in there whatever you're missing, and then create a pull request for us that we will take a look at and integrate. And similarly, if there are some problems with our language repository setups, you can fix them the same way. And especially if you want to contribute a language that we're currently not covering, then you just create your repository, work through that guide that is listed here on the website in implementing new practice repositories. There are some guidelines how we set these up, and then you just basically tell us you go here, you go there to one of the projects that you create an issue and tell us, hey, I have this new repository. Please look into adopting that. So that's how the project behind it is set up. We're maintaining that very actively at the moment because we think investing in a good way to write behavior-driven development or do BDD is very much worthwhile as a development method. So far that's the repository. What I want to show you is how to get going with fixing some smells. So what I will do is as I said, I will work in the Go code, which is kind of this repository, Cucumber Diseases Go. Let's talk about that layout and how to get there. So how to set it up is fairly simple. You just clone the repository locally, and then if you're in the main branch, it's usually in the state where we have all the smells that we have described on the page included, and you can just start working there. So let's talk a bit about the structure of the repository. So what I have done here is I have just cloned the repository, basically. What you can see here, all code that we have is based off the same test application. Let's talk about that for a moment. We have a file called customer.go, which is our implementation of a very, very simple and basic service. This service, you can imagine the setup as this is a service used in a bank for managing their customer accounts. It is very rudimentary because it's enough for getting a useful BDD feature going and working on that. So how this works is it is a service that allows you to create new customers, that allows you to, it's basically a list of customers, right? You can add customers. To the list. You can check whether they exist. You can remove them. You can search for them. So it's kind of a very simple CRUD interface. And there are some business rules in there, like any email will be first name and last name at mybank.com. The customer record can have first name, a last name, and a birthday. We don't have more data because we don't need more data at the moment. Then there is some business logic around duplications, which fields have to be included. So you can see from this code that a customer always, if you want to create them, has to have first name and the last name, but you must not have duplicate customers, right? That's basically how it works. All the functionality that we have is represented in that customer.feature file. Depending on the programming language you're using, you will find it at a different location. For Go, it's just on the top level, features, and then customer.feature. So this file, in a BDD style, describes all the business rules and functionalities by example that we have for our service. So there are different rules. There are rules for creating a customer with a username, for example. So this is how you should be able to create a successful new customer. Like they have to have a name, they have to, this is typical gherkin code. Like the first scenario. You should be able to successfully create a new customer. Given there's a customer with the name of Max and the customer has a surname of whatever and the customer's birthday is like this. And then when the customer is created, then the custom creation should be successful. Plain and simple. You find multiple scenarios. Also, like for the rule of customers must have a unique name. So given the customer name is Max Musterman, when the customer is created and then we create a second customer, so as they have different names, the first customer should be created, and the second customer should be created, and then there should be no error, right? We can find that customer again. On the other hand, we cannot create two customers with the same name, like the name is Max Musterman, and we try to create that user again. So when the customer is created, and when then the second customer is created, then the custom creation should fail. If you're a bit experienced with writing BDD in gherkin style scenarios, you will already see that there are some issues with how that is set up. You can imagine that this is a legacy application other people developed over years, and the setup is not perfect. It has grown. It really has grown because we added more and more features in a BDD style. So you may be able to spot some errors or issues with that feature file in the first place. Let's take a look at the Go test implementation. So what's going on here behind the scenes? Let me start here on top of the file. First off, this is set up with using Godog, which is the official Go Cucumber implementation. And it uses a fork that I created for fluent assertions, so that we can use that with Godog. So if you know fluent assert / verify, which is a package for fluent assertions in Go, my fork just adds a simple method of returning an error from an assertion and not failing the tests, because that is what Godog requires. So this is a typical Godog setup. Like this is the test features class. This is actually the test runner. It initializes the Godog test suite, uses an initialize scenario function that you will find on. We'll look at it in a moment, and set some pretty basic options like run pre-formatting, and we find our feature file in the features folder right up here. And then of course we run the suite, and if it doesn't run without an error, well, we print that there was an error. So then when you check out the repository, it already contains quite a lot of these test step functions. I use a dedicated test step struct here because there are some things that in the initial setup we want to pass around. Like we have the customer service available, we want to track errors, birthdays, of the different steps where we create the customers. So there's quite some data around, and we pass that around through that test steps. So that's why we implemented it that way. And if we scroll down a bit here, you can see our scenario initialization. What that basically does is it creates the test steps struct for the global context where we pass around some data, and then it implements the different steps. It just uses the very generic .step function to create a generic step. You could use here the more dedicated then, when, and given steps of Godog, which would be more tight. And that's also maybe something to look at when implementing. So that's a basic setup. If you check that out in this stage, let's open up a terminal here. This should run through, right? So if we just go here and put in the repository Go test, it will take a moment to set up the test runner and run through. And then we should see, okay, 11 scenarios, 41 steps, all of them passed, no error, because that is existing code, right? So that run through. So that's the base setup. This is where we are starting. And the first thing I want to start with is working on the first exercise, identifying the first smell. So just that you can see how this project is supposed to be used. So we go here to cucumberdiseases.github.io, and then we go to Deliberate Exercises, and here we can enter exercise 1, which is implement the missing then implementation. So obviously this is related to the first smell that we have registered, which is called missing then implementation, and that's quite a speaking name. So what's the problem here? This smell refers to steps within a gherkin scenario that are like then steps. but where the function is not doing anything. So what's the problem with that? So if we have a then step that just doesn't assert anything, well, that makes our test obsolete because we don't check any behavior. It effectively makes our BDD approach irrelevant, and it can lead to a lot of false negatives, because there are steps that will be passing, although we don't know whether the actual conditions are met and it really works. So what do we need to do? We need to find all the steps within our scenarios that lack assertions or are empty, and then choose a way to resolve them. Right? We could just implement the assertion. Maybe that step isn't required, and then we should remove it. So let's do that in our Go code. Oh, let me just take a look at the exercise here. So what's our task here? So first off, we should learn how to identify the step and understand how to remove it. So our task is, within the customer feature file, like the feature description, somewhere there is a then step that doesn't do anything. So we should find at least one of such steps and implement a correct assertion for it. Let's do that. Let's go there. We can either go through the customer feature and search for all like then steps, and then check in the so we could search for all the then steps and then check in the test scenario whether there's an implementation behind it, which the way this is written at the moment is the only way we can do. So let's see. Let's start at the top. Okay, so let's see. First then step. The customer creation should be successful. Maybe I'm going to create a second one here. Okay. And that one. Toggle. Okay, get rid of the file explorer in my editor. So left side, step implementation, right side, the feature file. Okay, so first then step, the customer creation should be successful. Okay, we search for that. The customer creation should be successful. Well, there's a function behind that. Let's search the customer creation should be successful. Okay, so first one. Oh, well, now, would you imagine that? Like the first one is already a hit. Like there is the function and it just returns null, but as you can see, it's a then step. So how do we fix that? So first off, I would go down there to be a bit more explicit and turn that from step into then. This is to Apache's beauty. But on the other hand, it makes explicit like this is a then step. Anybody who reads that code later on will more easily won't have to do what we just did now. Figure out like, oh, what's the then? How does it match there? And go in there. So let's GD. Okay, so now we have that, and now we can go to the implementation here and figure out what we should do. So what's the scenario here? Okay, there's a customer given the first name is Max and the customer last name is Masterman. He has a birthday. Okay, when the customer is created, then the customer creation should be successful. So how do we know whether we're successful or not? Let's take a look at the implementation for the customer is created step, which is conveniently up right here. What it does is, okay, it sets t.err, which is in our struct up here. We see it's a field for the error in our customer test steps. So the customer is created, here we are, and then it calls the customer service, adds a customer with the stored first name and last name and the default birthday. Okay, so what should we do here? This is clearly missing a verification. We're going to use the verify package, the verify module, and I think there are two things we should make sure. So or three things. We should, oh, maybe it's just one thing that we need to do actually. We need to figure out whether an error was returned from @customer. So let's say, okay. Oh, there's a more convenient function. Now verify.now error, and then we can just add t.error. And then now there's the special function as error that I implemented in my fork for Fluent assert verify, so that we can, as you see, this test step function, they always require an error or nil returned. So verify can't do that out of the box. So this is what I implemented to make it possible. Okay, so we save that, and at any time we do that, we should be able to run go test once again, and it should pass. Okay, cool. So that's basically the first fix that we do. So that's how you use the repository, going through the loop of taking a look at the exercise, figuring out what's the task, what has to be done, identify the smell, fix it, and then run the test again, and the tests always have to end up passing. I just fixed that one place. It could be that in the code, if you take a look at that, there are more implementations where for the then step, for example, the assertion is missing, right? Yeah, and that's how you use the project, and how you can work through these exercises. And hopefully by doing that, you learn how to write good Cucumber test code. That's the idea here. I will make some further videos where I go through each of the exercises step by step, but I think for an introduction, that should be enough. And I hope you have a great day, and I hope you find playing around with that little project valuable.